Hello everyone. In the previous session, we have completed center of mass and conservation of momentum, collision, everything was covered in the previous session. So in today's session, we are going to start with the rotational motion. That what is rotational motion? In this lecture, we are going to discuss about that. So I hope you have completed the question of the previous session actually. Just let me check that everything is working fine or not. So let's begin the session. Hi everyone. So first of all, when we talk about rotational motion or we talk about some bodies, then what is the first thing that we need to know that what is a rigid body? That what is a rigid body? As the name suggests, that rigid body is something which is rigid. Rigid means which cannot change its shape actually. That during the motion, for example, if this fan is moving in some direction, I think you can see that if this fan is moving in some direction, then its motion during the motion, its shape and size is intact and it's not changing. Then this body is called as rigid body. I think the words are clear to you that the body which does not change its shape and size during the motion. In other words, it can also be defined as, do you know that if I ask you that this is a body, can we break it in different, in very small particles? Or you can say body is made up of millions and millions of particles actually. So what is a rigid body? Rigid body is the body in which the distance or the separation between any two particles is constant. Now let me just explain it to you further. For example, what is mentioned here, the body in which separation between any two particles remains constant with the time is called rigid body. I think this thing is very much clear to you. What is a rigid body? Now, again, you can see the second definition that I have told you, the body which does not change its shape or size during the motion. Now, let me describe it to you. For example, let's suppose, let's take an example. Suppose this is a body. This is a body. And every body has number of particles in it. So I can say if this body has number of particles, like one particle, two particle, three, four, you can put millions of particles. So if this separation, this is the separation between these two particles. If this separation remains constant throughout the motion, then this body is known as rigid body. I think you are aware of the fact that I have told you. What is rigid body? In which the separation between particles remains constant. Now, moving further, moving ahead. If you have any doubt in this portion, then you can ask me. Otherwise, I am moving further. Okay. So now, what is the motion of a rigid body? A body, this body, what kind of motion it can possess? So generally, we can say that body may have translational motion. I am just naming translational motion. It may have pure rotational motion. I will describe it a little bit later. Pure rotational motion, or the ultimate thing, the body may have a combination of translational and rotational motion. That's the part that we are going to study at the later stage of the chapter. So now we are dealing with only two types of motion, translational motion and again with the rotational motion. So what is translational motion? What is a translational motion? Let me explain it to you. First of all, I am just saying few words. What you need to do, you need to just grasp those words and increase your focus. What I'm saying, the translational motion is the motion. For example, this is a body. This is a body. And this body is moving. There are millions of particles on this body. If during the motion from this position, I think I must remove the blur here. Okay. I say that body is moving from this position to this position, like from this position to this position. And if I say that path of each particle during the motion remains parallel, then the motion is known as translational motion. Is my word clear to you? Main thing, you need to catch up with the main thing, that if the path of each particle remains parallel to each other, then the motion is translational motion. For example, if you can see that this is the rectilinear motion. Now, look at the orientation of the notebook. This is oriented like that. If I say this is moving this way, the orientation of the body doesn't change. It's again in the same orientation. Then this motion is also known as translational motion. So what if I say what is translational motion? The motion in which path of the particles path of the particles is parallel to each other, is parallel to each other, then this motion is known as translational motion. Now translational motion can also be further divided in two types, like rectilinear and curvilinear. So give me a very small amount of time so that I can explain those things to you as well. Let's suppose this is a body. This is a body. I am drawing some random shapes so that you can just relate that we are talking about everybody, not some specific pen or notebook type bodies. Everybody, we are dealing with every kind of bodies, 2D, 3D, linear, everybody. So what I'm saying, suppose this body has three particles, A, B, and C. Now I am moving this body from this position to this position, from this position to this position. You can see that, and the body reaches don't match the shape of the body. Actually, they are randomly shaped bodies, so it's not uh, easy for me to redraw the shape of the body again. So now look at the particles. Look at the particles. The particle A has reached this point. A. B has moved this point, and C is here. Somewhere it just recalls me of relation kind of thing, relation and function that you have studied in mathematics kind of relation. So just don't go there actually. What is this? These are the three particles A and B, and after the motion, look at the path of these particles. These paths are parallel. So such kind of motion in which path of the particles are parallel to each other, as well as in a straight line, as well as in a straight line. So the path is straight line, straight line, and parallel. So such motion is known as rectilinear motion. Rectilinear motion is a type of translational motion. Translational motion is defined as in which path of the particles is parallel to each other. Now, another situation is, have a look at this situation. Suppose this is a body which again has three particles A, B, and C. Now, what I am saying that this body is moved like that. Have a look at my hand actually. This is a body, and this body, look at the orientation of my hand. This is in the vertically upward direction. So I am moving this body from this way to this way. Have a look at the path, this way to this way. But the orientation of my hand remains intact. It's same throughout the motion. When the orientation of body doesn't change, then the motion is known as translational motion. Clear? So that the body moves from this position to this position, somewhere like that. And the particles are A, B, and C. And the paths of these particles A, B, and C. Don't go with the some unparallelness due to the pen. But what you can see, all these paths are parallel, but not in a straight line. So such kind of translational motion is known as curvilinear motion. Such kind of motion is known as curvilinear motion. You can write it here, curvilinear motion. Now, the things written on the board are clear to you. You can reply in the chat box if you have any problem on the terms related to the screen. Otherwise, I am moving ahead. Okay. So moving further. Now, what is rotational motion? Till now, we have studied rigid body. What is the motion of rigid body? Translational motion. Now, second type of motion is rotational motion. Now, there is a clock. Yes, sir. Everything is clear, I think. Yeah. Very good. So, there is a clock on your screen that you can see. Just focus at the tip of the needle, at this point, at the tip of the needle. Can anyone see its motion? Just look at the tip of the needle of the minute hand, which is, I think this is a second hand, I think. So just look at the second hand and you can judge that this tip is moving in a circular path. This tip is moving in a circular path. Can you see that? Like that. One more thing that you can see from here, if you pick any point, if you pick any point on the needle like this point is moving in a circular path. So what I am saying that rotational motion of a rigid body is what? The motion in which every particle of the body moves in a circular path. Things to be remembered, things to be felt actually. The rotational motion is what? In which every particle of the body moves in a circular path. The next thing that may come in your mind is, sir, if there is a circular motion, then what is the center of that circular path? What is the center of that circular path in which particle is moving? So for that, you can see that. Can you tell me that this needle is rotating about which point? And everyone will answer that the needle is rotating about this point, which is highlighted by the laser pen actually. About this point now. So the body about which it is rotating is called as axis of rotation. You need to remember some words here, is called as axis of rotation. So this is axis of rotation. Ask yourself, have you seen any rotational motion in your life till now? Have you seen anything? I have shown you a clock actually. The needle is rotating. This is a rotational motion. Have you seen any other example? Can you tell me? Can anyone tell me any other example? Okay, someone has answered. Bicycle wheel, very good. It also rotates, very good. Can you see the fan there actually on your ceiling? If it's on or not? I don't know whether it's cold there or not. Actually, if you see the fan is also rotating. Whenever a body rotates, the first thing that we need to ask, whenever you see a body rotating, just ask yourself, what is the axis of rotation? What is the axis of rotation? Now, I will tell you how to identify the axis. Just look at the body and its rotational motion and divide the body in various points, various particles, and find the point which is actually not rotating or just doesn't look like rotating. For example, if I say, if I draw a point, this point, have a look at the point, this point. You will notice that this point is not rotating. Actually, this is at its place. For example, if I rotate this pen, if you can see, if I rotate this point, the point which is in my hand is at rest, is not moving. So axis of rotation will pass through such point which is not rotating. This is the one thing. Now, I will summarize the rotational motion. The rotational motion of a body or pure rotational motion is of a body is what? The motion in which every particle of the body moves in a circular path. And the center of the circular path is, have a look at these 2 points. This point is A and this point is B. This when this body rotates, this point A also rotates in a circular path, point B also rotates in a circular path, and the center lies on the axis of rotation. Center lies on the axis of rotation. So I am just summarizing the things on the next slide. What is rotational motion? The motion in which every particle of the body what? Of the rigid body moves in a circular path. Have you studied the circular motion? Na? You all know about circular motion. Three important parameters in the circular motion that were used. I think you all know that: angular displacement, angular velocity, angular acceleration, centripetal acceleration, centripetal force. You all know about these terms. I'm assuming this term. If you don't know, you can tell me here so that I can be more specific in describing those. So the motion in which every particle of the body moves in a circular path, this is the first point. Second point that you can imagine, the center of the circular path, these are the punchlines actually. These are the punchlines. The center of the circular path is on the axis. This is again an important thing. Now, the third point, have a look at that previous slide. Can you notice that point A has smaller radius and point B or particle B has larger radius? Can you see that? That radius of particle A and B revolving in a circular path is different. If the radius is different, do you know the relation that linear velocity is what? Can anyone know that what is the linear velocity in a circular motion? For example, this body is rotating by angular velocity omega. This body is rotating with the angular velocity of omega. So what is the relation between angular velocity and linear velocity? Again, now, I think you are not going to answer anything now. So I am just assuming that you know these things. Again, I'm repeating one more time. When this body rotates, keep this thing in mind. And if you have something to rotate, then you can rotate it as well. When the body rotates, the every particle rotates in a circular path, and the time period of revolution is same for every particle. In which A completes one revolution is same the time in which B will complete one revolution. ऐसा तो नहीं होगा ना कि बॉडी घूम के वापस आ गई, ए पीछे छूट गया. A and B both will come to the same point at the same time, because the separation between them should remain constant for a rigid body. So that's what I am saying, that the time of completion of one revolution is same for every particle. So this is our next point. The time period for every particle is same. This is the base of the chapter. Actually, if you don't remember those points, then it will be difficult for you. Okay. Now, next point is, if the time period is same, then one more thing is same in the complete situation, that is the angular velocity. The angular velocity of each particle is same. Now, if I talk about some circular motion things here, for example, a body is moving in a circular path like that. A body is moving in a circular, a particle in fact is moving in a circular path like that. And this is the particle. This is moving in a circular path with a velocity omega. And the radius of the circular path, I am assuming it to be r. Then at every instant, you all know that, I hope, that linear velocity, how you calculate, how you find the direction of linear velocity is the tangent. If I ask you that at this point, what is the direction of linear velocity? You will draw a tangent at this point. This is the direction of linear velocity. So what is the magnitude of this linear velocity? You will say that, sir, linear velocity is what? V is equals to R omega. This is the relation that you have derived in the circular motion that you have studied in the 2D motion of kinematics. So V is equals to R omega. This is the relation. V is the linear velocity, omega is the angular velocity, R is the radius. Now, come back to the previous slide. Just have a look. If I say V is equals to R omega, can you answer which particle will have more linear velocity? Can anyone answer? Which particle will have more linear velocity? Particle A or B? Can anyone answer quickly? Quickly, quickly. Be responsive, guys. ऐसे नहीं ना होगा. The particle which has more radius will have more linear velocity. That means A will have less velocity as compared to B. Clear? Then what can you say about a particle C? If I draw a particle C, what will be its linear velocity? What will be its linear velocity? You will say, sir, this particle is on the axis itself, so its velocity will be zero. Its velocity will be zero. Someone has answered zero. Very good. Okay. So now moving further. Next point is the particle near to the or nearer to the axis will have lesser velocity, linear velocity. Now, these are few important points that you need to know. Again, if I just want to increase the level, then I can add one more thing here. But that would be a difficult thing for you. That is not related to rigid body, not related to rotational motion, not related to translational motion. It's related to every kind of motion. This is a golden punchline. What does that golden punchline say? If this is a body, this is a rigid body. What is the definition of rigid body? That separation between 2 points remains constant. This is the definition of the rigid body. Na? And suppose this body is rotating about this axis. So all these two particles, A or B, will have different linear velocities. Will have different linear velocities. And you know that V equals to R omega. So what I'm saying, suppose at some instant, again, this is a difficult thing. So try to listen carefully. Suppose particle B has some linear velocity this direction, and this has some velocity in this direction. Like this is V1 and this is V2. This is the velocity of the particles A and B, linear velocities of the particles A and B during the motion. Then the main thing is, if I say that this angle is alpha and this angle is beta, things are going difficult now. Then the component of these velocities along the line joining the particle will be equal. तो समझ में नहीं आया आपके. You just didn't get what I am saying. I'm repeating my words. What I'm saying, then the velocity component of velocity, you know how to take the components. If I want to take the component of v1 in this direction, then this component will be what? This component will be what? Can anyone answer? This component will be v1 cos alpha. Component of v2 in this direction is v2 cos beta. So what I am saying, that component of velocities along the line joining the particles will be equal. If those components were not equal, if I say that this is greater than this term, then the particle will come close to each other. And what is the definition of rigid body? They must remain at the same position. The separation between them should not change. So what is the conclusion here? The most important point. Okay, I will tell you. The component of velocities along the line joining the particle will be same, or you can say equal, or you can say equal. Now, let me explain you one more time. For example, this is a phone. This is in front of you in your hand. What I'm saying, if I rotate this phone from the center, it will rotate like that. It will rotate like that. Then focus any 2 points. Focus any 2 points. These 2 points will have different linear velocities. How we can say that? Because v is equals to r omega. If you look at your fan in front of on your ceiling, the point nearer to this axis, nearer to the center, are moving slower than the points away from the center. So this is the difference between the velocities of the particles. But what will remain constant is the component of the velocity along the line joining them. This is a very important question. Few important questions came from this point. Always. So some important points are mentioned on your screen. I hope you can write them. I hope you can write them. After that, we will move little bit further. Have you noticed everything? No. Next point is kinematics of rotational motion. What is kinematics of rotational motion? You have studied about kinematics equation. There were three equations. There were three equations of kinematics. Do you know that those three equations? It's not working. In translational motion, very good. V equals to U plus AT. Very good. Two more equations were there. And rotational motion. First of all, during the rotational motion, every particle is moving in a circular path. So we need to know the parameters that are used in circular motion. I am describing those parameters here so that you will not get confused. The important parameters in circular motion are, okay, kind of three important parameters of circular motion are, first thing is theta, that I will use. Theta is what? Angular displacement. You can complete it angular displacement. Next term we are going to use is either omega or omega naught. We will use that later. Omega is what? Angular velocity. Next term is what? Alpha. Alpha is what? Angular acceleration. So these three terms are going to be used here. If I write equation in translational motion during the kinematics when acceleration was constant, then first equation was v equals to u plus at. You don't need to remember the equation. What you need to do, you just need to learn how to transform the equation from translational to rotational motion. So v is equals to u plus at. In this term, v was the final velocity, u was the initial velocity, a was the acceleration. So I will replace these terms in rotational motion, and I can write that velocities. These two terms are velocity, initial and final. So I am writing here velocity is represented by omega is equals to omega naught plus alpha. Again, I am saying v and u are the velocities. So omega and omega naught are the velocities. Alpha is the acceleration. T is the time. Here, omega is the final angular velocity. Omega naught is the initial angular velocity. Second equation that you all know that S is equals to ut plus half a t square. Can anyone replace it in rotational motion? You can definitely replace it. S is what? Displacement. So in rotational motion, displacement is what? Theta is equals to initial velocity into time omega naught t plus half acceleration times t square. The third equation is v square equals to u square plus 2as. Just quickly reply, v square is final velocity, that is omega square. Initial velocity, omega naught square, plus 2 alpha, and s is what? Displacement, which is denoted by theta. Have you learned how to transform these equations? Then there is a question on the next slide. So be prepared, either write down these equations so that you can calculate. Otherwise, it will be difficult for you to solve the question. I will give you 1 minute, complete 1 minute to solve the question. Moving on the next slide. Now, you have complete 1 minute. Pick up your pen, pick up your notebook, and try to solve the question. First of all, you need to identify the motor of an engine is rotating about its axis with an angular velocity of 100 revolution per minute. That means you were given some angular velocity. First of all, write it down. Angular velocity of 100 revolution per minute. It comes to rest in 15 seconds after being switched off. That means motor was switched off and it comes to rest after 15 seconds. So one thing to be noted here, it comes to rest after 15 seconds. Your time is given in seconds. And here the unit is minute. So one thing in your mind that should come actually, that you need to transform the unit. So 100 revolution per minute can be transformed to revolution per second. And that can be written as 100 divided by 1 minute has 60 seconds divided by 60 revolution per second. You can easily write it as 5 by 3 revolution per second. This is what omega is. Assuming constant angular acceleration, deceleration, calculate the number of revolution made by it before coming to rest. Now, the question is, listen to me. Has anyone solved it? Got the answer? Can someone tell me that this fan was initially, motor was initially on, it was rotating with some velocity, then it was switched off, and slowly it comes to rest. So can you see that initially it was moving, finally it was stopped. So the initial velocity is 100 revolution per second. So this is what omega naught. Final velocity of the motor is, you will say that final velocity of the wheel is zero because it has stopped. Because it has stopped. Now what you need to calculate? You need to calculate the displacement, number of revolution. That means angular displacement they were asking you. So what you can do, first of all, you need to calculate the deceleration, because displacement is what? If you say displacement is S is equals to, if I say in terms of angular displacement, you will write theta is equals to omega naught t plus half alpha e square. Is it correct? Or you can use omega square equals to omega naught square plus 2 alpha theta. In all these two equations, you need to calculate alpha. So first of all, I am going to calculate alpha. After that, you can choose any of these two equations to solve the theta. Now, from first equation, I can say first equation is what? If you don't remember the rigid body dynamics, then you can say V equals to U plus AT. V is what? Final velocity is equals to initial velocity plus alpha t. Omega is 0. Omega naught is 5 by 3 plus alpha, and t is what? 15 seconds. Can you solve this equation, this part, as alpha is equals to, or you can say 15 alpha is equals to minus 5 by 3. So alpha is equals to minus 1 by 9 revolution per second square. This is what alpha. Now put this alpha in any of these two equations and you will get the answer. I am putting this alpha in the first equation, in this equation. So theta is what? Omega naught t. Omega naught is what? 5 by 3. T is what? 15 seconds. Plus 1 by 2. Alpha is what? 1 by 9. And which is minus 1 by 9. So I put minus here. Into t square is what? 15 into 15. Can anyone solve this? We will divide 3 by 5. So that is 25 minus, if I again divide 25 by 2. So that is 12.5 revolutions. So what is the right answer for the question? 12.5 revolutions. This much, 12.5 revolutions will be made by the motor before coming to rest. These are the basic things that we have studied in this lecture till now. Now again, just have a look at the question, have a look at the solution. Now we will move further. Okay. This is again a difficult topic for you guys. Okay, sure. So first of all, what we need to do, we need to understand the question. If you want to repeat it, this question, we need to understand the question. Like suppose, just forget about the motor, engine, everything. Just look at your fan. The fan is rotating initially with some velocity that was 100 revolutions per minute. After that, you switch off the fan, and it will slowly decrease, 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 and it ultimately comes to rest. So what are they saying? They are saying that it stops in 15 seconds. So the initial velocity is 100 revolution per minute. This one is the initial velocity. Final velocity of the wheel will be zero, of the fan will be zero because it comes to rest. What we need to do, that before coming to rest, you can see that fan revolves multiple times before coming to rest. So how many revolutions it made before coming to rest? That's what we need to calculate. What we have done, we first calculated the angular acceleration. Without knowing the angular acceleration, we cannot solve it. So the angular acceleration, for that we use the first equation. This is the kinematics, and nothing else. V equals to u plus at. V is the final velocity, which is zero. U is the initial velocity, which is pi by 3, alpha and t. After solving, we got alpha here. Put this alpha in either of the two equations, you will get theta. Theta is what? Angular displacement that we need to calculate. And the angular displacement was 12.5 revolutions. So what the answer is, it made 12.5 revolutions. If you want me to solve it again, or you want me to calculate further, so you can ask me. Otherwise, is this clear to you? Is there any doubt that you want to ask? I think Ruchita. No, sir. Is everything clear now? So now I will summarize the things because next topic is again very difficult for you guys. So let me just recall those things. The main thing that you need to know in tomorrow's class, that is this one. These few points you should know in tomorrow's class. Otherwise, it will be difficult for you to understand all the things, because tomorrow's session is going to be the difficult one for you. One more time, I am saying rigid body rotation is the difficult chapter of your syllabus. So, what you need to do, be present every day. Like today, you are good in numbers. So, it feels good actually that you are good in numbers. So, let's hope for the best. You will stay there. And in tomorrow's session, we will study some difficult things. So, be prepared for that. Till then, bye bye, everyone. I'm ending. If you want anyone if want to ask something, then they can ask. Otherwise, I'm ending the session. Okay. Thank you. Thank you, everyone. Bye. Thank you.
As Optis suggested, ki Optis is nothing but this is the branch of physics where we study the behavior of the light. Okay, so if we discuss about the electromagnetic spectrum, we know that ki in electromagnetic spectrum, these are various types of ray that is present in electromagnetic spectrum. If this spectrum is arranged in the increasing order of wavelength, so we can say that this is the increasing order of wavelength. We can say that radio wave having the maximum wavelength and the gamma ray having minimum wavelength. Okay, one formula we also know how wavelength is related to energy, and that is the formula that E equal to hc upon lambda. So by this formula, we can say that ki h and c are constant here. Here c is the speed of light in vacuum, h is the Planck constant. So in this formula, we can say that ki the energy that is inversely proportional to wavelength. we can say that if the gamma ray having minimum energy, minimum wavelength, we can say that the energy contained by the gamma ray is maximum and the energy contained by the radio wave is minimum. Okay, so I am not too much interested that whole electromagnetic spectrum. We only focus in the visible portion because the visible portion for which our light is sensible and our light is active, our eyes is active for only visible region. So we can say that in whole electromagnetic spectrum, this is the part which our light eye can sense, our eye can detect, and this portion that in the electromagnetic spectrum, the portion for which our eye detect and eye senses, we can say the portion of electromagnetic spectrum is known as the visible portion, and the portion having the wavelength approximately, if we discuss about the wavelength, that is the 4,000 angstrom to that is nothing but 8,000 angstrom. This is the particular range of wavelength for which our eye is active, and this is the segment of electromagnetic spectrum that visible portion is in study of the visible portion. We can say that we can say this is the study of the light, right? So whenever somebody asks to me what is the light, so light is nothing but light is the study of the visible portion in electromagnetic spectrum, and we know that our visible portion that is lie between 4,000 angstrom to 8,000 angstrom. Okay, but what is the meaning of ray here? Firstly, we understand the concept of the optics. Next, we have to understand what is the meaning of the ray. Okay, the meaning of the ray are the geometrical word. What is the geometrical word suggest here? We can say कि if light is traveling in straight line path, the this behavior of light is observed only when the dimension of the object that involve with light, that interact with light, having much greater than as compared to wavelength of light. We can say that we only we only experience the ray behavior of light when the dimension of object is much greater than wavelength of light. So in this type of study of light is known as the ray behavior of light and the ray optics, because in the ray optics there is the geometry portion also involved, basic geometry, that is the straight line propagation of the light. So this is also known as the geometrical optics. We can say in the straight line behavior in the ray optics, we discuss the rectilinear propagation of light. That is the rectilinear propagation of light, right? So in ray optics, we are going to discuss about the rectilinear propagation and some geometrical aspect also. Okay, nice. So here, our next term is the beam and its type. Before going to understand the concept of reflection, we have to understand what is the beam. And if we talk about the beam, so beam, hello, हेलो, हाँ सर कर दिया था. ओके, okay. So if we talk about beam, so firstly, if we define the term beam, we have to understand the word ray. Okay. So we already discussed that light is moving in a rectilinear propagation in the straight line path. We can say that if consider, suppose this is the source of light, and light is emerging from this source in this manner. So we can say that light is coming from any source, that is the bundles of ray. And these bundles of ray is nothing but this is known as the beam of light. So in the ray optics, we can consider whenever light is coming from a source or any object, the light is come in the form of beam. So next, if we discuss about the how many types of beam, basically there are three types of beam, that is depending upon which type of object is present. That is, one is the converging beam, second one is the parallel beam, and the third one is the diverging beam. Guys, if we discuss about the converging beam, so the beam are shown in this manner. We can say if they are moving and concentrated towards a point, we can say this type of beam is known as the converging beam. In the parallel beam, they are moving in such a manner that this type of beam is known as the parallel beam. In the case of diverging beam, the distance between ray is continuously increasing as they move from a point. We can say, if we want to discuss about the diverging beam, so we can say this is nothing but this is the example of our diverging beam. So there are some examples of the beam, that is the converging, parallel, and diverging. Next, we have discussed the what is the law of reflection. Law of reflection in our earlier classes, that class 6, 7, 8, we already discussed what is the law of reflection. Okay, so in law of reflection, there are three types of ray is involved. Actually, what happened? The ray is incoming from any object and any source, that we can say this is our incident ray. When incident ray strike at a given surface, if we consider the surface is mirror, we then suppose that the surface is polished on one surface, so that most of the portion of light that will get reflected back. So this type of surface is known as the mirror, having the coating of some oxide, silver oxide on the opposite surface, so that most of the ray will reflected back. And we can say that the incident ray is strike at a given point, say this point is O. So this ray is known as incident ray, and the line which is perpendicular to given surface where the ray is strike, we can say this line is known as the normal. And in the plane surface, that normal is always perpendicular to surface. The angle made by incident ray with the normal is known as the angle of incidence, right? And the reflected ray, this is our reflected ray. The angle made by the reflected ray with normal, that is known as the angle of reflection. So according to law of reflection, that is the two basic law. One is the incident ray, normal, and reflected ray, that all lie in the same plane. And the second, the angle of incidence is equal to angle of reflection. We can say the angle of incidence is must be equal to angle of reflection. And we can say the incident ray, reflected ray, and normal, all they lie in same plane. So if we describe this thing by using mathematics, we know that if we represent all these three rays by a unit vector, so if we say if we represent incident ray by a unit vector, that is E cap, normal by a unit vector, that is R cap, and reflected ray by a unit vector R cap. So here what is first ray is saying that incident ray, reflected ray, and normal lie in same plane. It must say the all three ray lie in same plane. It means all three ray are coplanar. If all three ray are coplanar, so how mathematically we can say that the box of E, R, and N cap is must be equal to 0. This is the condition of the coplanarity of the three vector. and this can be also written in this manner, that E cross R and dot n cap equal to 0. Sometimes if the equation is given in the form of incident ray, reflected ray, and we have to find out the unit vector along the normal, by using this equation we can find out the unit vector along the normal. So this is also very useful, and we have to keep in this formula in our mind. Okay, so let's move for the plane mirror. In the plane mirror, what is the object, image, and its properties? So first of all, if I am going to discuss the plane mirror, so we can say that any surface something like this, if the one side is polished, some required oxide surface, so that most of the ray reflected back. This type of surface is known as the plane mirror. And here, if you want to define what is the object. Okay, so object where the ray is emerging from, we can say that is the object. So how object is defined? This is defined, it is the intersection point of the incident ray. How this is defined? Intersection point of the incident ray. Okay, so where incident ray strike, we can say that is the object. If we consider a case, say this is our plane mirror and this is our object, we can say कि if ray is emerging from the object, we can also say that कि these two emerging ray that is intersect at point O, we can say कि this is O is nothing but this is the object, because this is the intersection point of the incident ray. Okay, so there are two types of object. One is the real object and another is the virtual object. What is the real object? It is the intersection of diverging incident ray. Here in this diagram, it is clear that these two rays are diverging type because the gap between the ray is continuously increasing. We can say that this O is nothing but this O is our real object. This O is our real object. And vice versa, if you want to define our the virtual object, so how we can say what is the virtual object? Let's consider one case again. Suppose that if our object is lie in this manner, that inside the mirror. So what we can say that if object is lie inside the mirror, so we can say after reflection, the ray is moving in this way and the ray is moving in this way. We can say if they follow the law of reflection, we can say that this is nothing but this is our incident ray, and that not really meet at point O, that must appear that they are emerging from point O. We can say that this O is behaving like as our virtual object. This O is behaving like as our virtual object. So what we understand from here, whenever real object is given, to we can say intersection of the diverging ray, and what is the virtual object? That intersection of the converging ray. The same thing happen for the image also, but in the different manner. If we talk about the real image, the intersection of the converging reflected or refracted ray, because both phenomena are possible. We can say that whenever we are going to consider the reflection, I am not talking about, at the same time we are not discussing about the refraction phenomena. So here, if we are going to take the same example, the example that we are having taken from the real object, we can say if this is our real object, right? So we can say the ray is emerging from this object and that is strike on the mirror. When the image is strikes on, when the ray strikes on the mirror, we have to draw a normal. If we draw a normal, we can say this is the normal one. And according to law of reflection, whatever angle made by the incident ray, the same angle made by this reflected ray R1. And the same thing also happen here. We can say if this angle is theta 2, this angle is also theta 2, right? If we extend this ray, this reflected ray in this direction, because this is what is image? That is the intersection point of the reflected ray. That is the very, very important point. So if we trace back this ray in this manner and this manner, then somewhere at a given point inside the mirror, they are appearing that just like to meet, not meet in actual, but they are appearing yet they want to meet at this point, and we can say because this is the intersection point of the reflected ray, we can say this is our image, and ray are not really like to meet. We can say this is our virtual image. This is our virtual image. I hope this is clear. Whenever a real object, and this object is our real object, right? So whenever real object is given, plane mirror always form a virtual image. That is the very, very important point. In the plane mirror, real object always form a virtual image. Vice and versa. If we consider, guys, if we consider that this is object that lie inside somewhere inside the mirror, we can say that this is nothing but this is our incident ray. Okay, if this is our incident ray, and we can say that the incident ray that we show here, that is the dash dash, because these ray is not real, so we can say that this is our incident ray, and because that lie inside the mirror, we can say this is nothing but this is our virtual object. This is our virtual object. Okay, what happened? If the ray strike here, we can say the ray is moving in this direction, and this ray is moving in this direction. But what will happen after the reflection? If reflection is happen here, we can say that after reflection, we have to draw a normal here, and we can say that the ray is moving in this direction. So the ray is also moving in this direction. If we draw a normal, we can say this is the reflected ray 1, this is the reflected ray 2. If we join reflected ray in the backward direction in this manner, this is nothing but this is the intersection of the reflected ray. And in this case, in reality, the two reflected ray intersect to each other. So we can say this is nothing but this is our real image. Okay, so we can say that in virtual object we can consider that the ray is coming in something direction in this sense, and after we can say that after reflection from this mirror, the image is formed at this side. We can say what is the learning here? The real object always form a virtual image, and a virtual object always form a real image. Okay. What is the image formation by plane mirror? How image is formed? As earlier I discussed, if suppose this is our object, and if the ray coming from this object that is incident on this mirror at any point, we can say this point is A. Then we have to draw a normal so that we will trace and we will draw the reflected ray. If we consider that, if suppose if this angle is theta, so by the law of reflection, this angle must be equal to theta also. Okay. We know that if you want to draw the image, we must know at least two ray, at least intersection of two ray. So let we consider that is our second ray. We consider suppose this is our second ray somewhere not in the normal direction, right? So we have to again draw normal, so we can say this is our normal. Okay, if this angle is theta, so we can say this angle is also theta. Okay, so here we can say that if this angle is theta, and we can say that guy after the symmetry, what we can say that the reflection of this ray is something like this. Okay, The reflection of this ray is something like this. What we can say that if we extend this ray in backward direction, they must appear to meet at this point, and this is nothing but this is our image. And by symmetry, what we can say that in the perpendicular direction of the mirror, the object distance from the mirror must be equal to the image distance from the plane mirror. So we can say that in the case of plane mirror, the object distance from the mirror must be equal to the image distance from the mirror, but in the opposite direction. Okay. We have to also know that in the opposite direction, and by the symmetry, by using the triangle of congruency of the triangle, we can also prove that these two triangles are the congruent to each other, and we can say by congruency, this angle that we must be, if this angle is theta, this angle is theta, and by symmetry we can say this angle is theta. So we can say this side must be equal to this side. So we have to also keep in mind in plane mirror, object distance from mirror must be equal to image distance from the mirror. There are some properties that image formed by the plane mirror, that is I already discussed. It forms a real image of the virtual object, and vice versa, virtual image of a real object. The distance of object from the mirror is also equal to distance of image from the mirror. We can say whenever whatever orientation is given of the plane mirror, suppose that if object is lie here and we have to draw the image of this object, we can consider at least two ray. This is our consider this is our first ray, and suppose this is our second ray. Okay, if we draw the normal here, this is the normal. We can say this is our first reflected ray, and if we draw normal here, we can say this is our second reflected ray. If we join these two rays in backward direction in this manner and in this manner, we can say that at somewhere at a given point here, the two rays must meeting to each other. What we can say that again the distance that is in perpendicular direction from the mirror, that distance of object from the mirror must be equal to distance of mirror from the image. Okay. And one thing also we have to keep in mind, the size of image is same as the size of object whenever an extended object is given. Suppose if I consider this is a extended object AB and we have to draw the image of this object. We have to keep in mind a extended object also made from multiple points. We can say that firstly we have to draw the image of point A. By symmetry we can say if this distance is D naught, the same image formed by the mirror, that is the opposite direction, that is the at the distance D naught, that is A dash. If we want to draw the image of point B, so we can say the B is also at the same distance, that is the D naught. We can say the same virtual image form, that is the B dash. Okay, the same size of image of an extended object that is formed by our plane mirror, right? The next segment is the velocity of image. What is the velocity of image? Suppose if a plane mirror is given and object is given and object start moving, that is there are two possibility, that towards the mirror and away from the mirror. Okay, or another case at any angle to, and at any angle if object is moving with respect to mirror. So then what we have to do, because if any object that change its position with respect to time, so we can say it must possess some velocity. So in this manner, at the constraint is the condition of the law of reflection must follow at each and every point. We can say that after considering all the points, what is the velocity of image? So if we consider the situation, what is the situation, guys? Suppose our if you consider that this is our object, okay, and the object is moving in this direction, and the velocity of object is given VO, right? And we can say that this is our mirror. We can say that this is the velocity of object with respect to mirror. This is the velocity of object, that is the with respect to mirror. And if we draw a perpendicular here, we can say if this angle is theta. So there are two components. One is the perpendicular component and another is the component that is parallel. Okay, so if we break two component in the another diagram, we can say that if this is the component that is the perpendicular to plane mirror, this is perpendicular component, that is the perpendicular component, and another component that is the in this direction. So we can say this is the parallel to length of mirror. This is the parallel component. Okay. So what is the law? If this is the object, so then why the symmetry? We can say the image is formed. The image, if this is object AB, so we can say if you draw the image at any instant, so we can say this is our A dash and this is our B dash, right? So this is our image. Okay. And we know that continuously the position of object is changing. So we can divide it to two segments. The one component of velocity, that is the parallel to length of mirror, that is the V parallel, and the another component that is the perpendicular to length of mirror, that is the V perpendicular. And we know that whatever distance that is covered by object towards the mirror, the same distance covered by image towards the object, in order to make the equation valid, that DO equal to DI, that object distance at any instant must be equal to image distance. So what we can conclude here, we can say that velocity of object with respect, one thing we have to also mind with respect to mirror, velocity of object with respect to mirror in parallel direction, that must be equal to velocity of image with respect to mirror in parallel direction, because we know that this in this distance there is no rule of the distance, and that is always same and the same orientation. That's why we have to put a same sign here. But for the perpendicular direction, we can say velocity of object with respect to mirror in perpendicular direction. If object is moving either, we can say image must moving in this direction. And we know that the velocity is a vector quantity. If we consider this direction is positive, so we must obey this direction is negative. We can say the velocity of image with respect to mirror, that must possess a negative sign here, and this is nothing but this is the velocity of image in two different directions. I hope this is clear, and this is valid for the perpendicular direction. So here, whatever question is given, we must break two components. What is the parallel to mirror and another is the perpendicular to mirror. And we know that the parallel component not going to change their direction. We can say whatever the velocity of object with respect to mirror, the same velocity of image with respect to mirror. But what will happen in the case of that is the perpendicular direction to the mirror? Whatever distance covered by object was the mirror, the same distance covered by with respect to time by image, but in opposite direction. That's why we have to put negative sign there. The next segment, that is the mirrors at an angle. Sometimes mirrors at an angle is given and we have to find out the total number of images formed. So in this case, what we have to do, suppose if we consider the case, suppose this is the our mirror, say this is the M1 and this is our mirror, say this is mirror M2. Okay, and suppose this is the object that is kept. There is two possibility. Either object O is kept at the angle bisector or apart from the angle bisector. Okay. So if we kept object at angle bisector and the angle between two mirror is the theta, then we have to firstly check what is the 360 upon theta here. If we find the value of 360 upon theta, and let's say this value is n. If this value is an integer, if n is our integer, so then we can say that the number of image form that is the less than n, because of the symmetry. We can say in this case number of image is always less than n. What is the another case? Suppose if n is odd integer, suppose if n is odd integer, suppose 1, 3, 5, such like this type of number 3, 5, 7. In this case, there are further two possibilities. If object lie at an angle bisector, if n is an odd number and object lie at angle bisector, then again by symmetry the image is less by 1, that is the image is n by 1. If the object is not lie on this line, object is somewhere here and here also. So in this case, the number of image is n. Suppose if n not come integer, so then we have to count manually. Okay, then we have to count manually. So if we consider a case, suppose if theta is given 90 degrees and we have to find out the number of image. So firstly, we have to find out the value of n, that 360 upon 90, and this value will become 4. Okay, we know that 4 is our even integer. So in this case, we can say in the case of even integer, we can say number of image is nothing but less than 4 by 1, that is the 3. So three number of image are possible in the case of plane mirror when two plane mirror incline to each other at 90 degrees. In this manner, we can calculate how many numbers of image are formed. Okay. So let's move for very important segment, and that is the spherical mirror. Okay. If we talk about regarding JEE and NEET, so this is very important. We have to understand the concept of the spherical mirror. What is the spherical mirror? This is nothing but the part of sphere. Okay. So suppose if we consider this is our sphere and this is nothing but the center of curvature. This is the center of sphere. If we consider that this is our sphere and this is the center, this is the radius. So here C is known as the center of curvature and R is known as the radius of curvature, right? And whatever that is height of this curvature is given, that is known as the aperture. Okay, so we can say these are the parameters related to any spherical mirror, that is the center of curvature, radius of curvature, and the aperture. If we cut this hollow sphere in such that like this, if we cut from there and if we highlight only this portion, so this type of portion, we can see this type of portion is known as the convex mirror. This type of portion, that is bulge portion is open for the incident direction of ray. We can see this type of portion of the mirror is known as the convex mirror, and on the opposite side, if the concave portion is open for the incident direction of the ray, we can say this is known as our concave mirror. This is known as our concave mirror. The most symmetric point of the aperture is known as the pole, and the line joining pole and center of curvature is known as the principal axis, right? So we can say if we consider this is our concave mirror, and this is nothing but this is the center of curvature of this mirror, and the distance between the center of curvature from the pole, that is known as the radius of curvature. The symmetric point is known as the pole, and we have to know one thing: the object that is placed, that is the cavity portion, front of the cavity portion. So we can say this is the object and ray is coming from the object. So something like this, we can say this will going to happen in the case of spherical mirror. Okay, some important note point: that line passing from the center of curvature will be normal to mirror. We already know that in talk about the circle, if we talk about the sphere, that this is our tangent and this is our normal, and normal always passing through the center. So we can say line passing from center of curvature will be normal to mirror. The ray which is very close to principal axis make small angle with normal at point of incidence is called paraxial ray. According to this sentence, we can say that the ray which is very close to principal axis and make small angle with normal at a point of incidence. We can say if this is our center of curvature, so this is our normal. If this angle is theta is very small, we can say that these ray is known as the paraxial ray. These known as ray is known as paraxial ray. Okay. On the opposite side, if we say that these ray that is far away from the principal axis, then the angle made by no, incident ray from the normal that is much greater than the previous case, and such type of ray is marginal ray. But in ray optics, most of the 90% case, we only consider that is the paraxial ray. There are some assumptions are taken only for the paraxial ray. Okay. What is the focus and focal length of mirror? Okay. So that is important relation, and we have to know that when we are talking about the concave mirror, we can say polished on this side. And suppose if this is the center, and what is the focus? If the ray is coming from parallel to ray is coming from, consider that infinite distance. Source is keeping at the infinite distance and ray is parallel to principal axis. Then after reflection, what will happen? The ray must be passing through a point. That point is known as the focus. Okay, so we can say this is our focal point, and in the case of the paraxial ray, F is always R by 2. So we can also say that if this is the direction of the incident ray, and what is the sign convention? Sign convention that is chosen in such a way, the direction of incident ray always take positive. Okay, we know that the distance is always measured from the pole. The distance which lie along the and in the direction of incident ray taken positive, and opposite to direction of incident ray that considered negative. Suppose if you want to measure this focal length, we can say from pole, in order to measure the focal length, we have to move in this direction. So we can say this is opposite direction of the incident ray. So we can say in case of concave mirror, the focal length is negative. We can say in case of concave mirror, focal length is always negative. Okay. One is the focal plane, that is the plane passing through focus and perpendicular to principal axis. So what is the focal plane? We can say that a plane that is passing through focus and perpendicular to principal axis. If we consider a plane something like this, if a ray is coming in this manner, that is the parallel ray coming in this manner, and after reflection, they will meeting at a given point. Suppose if we consider the point that is above or below to principal axis, and that must, we can say that this point is known as our focal plane, something like this. And if we intersect, the ray intersect at this point, we can say this point lie must below a focal point. If we consider a plane passing through this point, then this plane is known as focal plane. Okay, so what is the focal plane? Focal plane is a plane that is passing through focal point. Okay. Here, we already discussed about that is what is the sign convention. In the case of concave mirror, one thing we have to keep in our mind, in the case of the concave mirror, focal length is negative, radius of curvature is also negative. Here, focal length is positive, radius of curvature is also positive. Okay, and distance is always measured from the pole. The ray passing through are directed toward the center of curvature after reflection from mirror retraces its path. According to this, a line passing through normal that will retrace back in it to its original path. Why this is happening? Because we apply the law of reflection. So along the normal incidence, we can say whatever angle, suppose this is the center and light is going in this direction. We can say this is the direction of normal also, this is the direction of incident ray also. So angle I is also 0. For the application of the law of reflection, we can say angle R must be also equal to 0. That's why ray will also retrace its path. What is the mirror equation? Guys, if we're talking about the mirror equation, that is the very important regarding mirror formula and mirror equation. 1 by f equal to 1 by u plus 1 by e. Sometimes we have to find out the image coordinate. That's why we have to transfer 1 by f minus 1 by u. We can say this is nothing but u minus f upon u f. So this is nothing but 1 by v, that v can be written as u f upon u minus f. Sometimes object coordinate focal is already given and we have to find out the image coordinate, and by using this formula we can directly find out the image coordinate. One thing we have to keep in our mind, u is nothing but object distance. It is the coordinate of object. Okay. So according to whatever we have learned in sign convention, we have to very much careful whenever we have to going to choose the sign of u, v and f. Okay. What is the magnification? There are two types of magnification. Here we have to discuss about the linear or the transverse magnification. That is nothing but height of image and height of object. Okay. So we can say as image formed by the mirror, that is how much enlarged or diminished with respect to original size of object. That comparison is known as the magnification. Okay, so here we can say linear magnification, this can be written as height of image upon height of object, and this can be also written as minus v upon u. So here, if hi is greater than h naught, we can say magnification is greater than 1. In this case, in large image form. If height of image is less than height of object, in this case, diminished image. If nature-wise, you are talking about, if magnification is negative, we can say inverted image. If magnification is positive, we can the erect image. Okay. One thing we have to keep in mind, if we talk about the case of the concave mirror, if we discuss the case of the concave mirror, one thing we have to very much clear about the concave mirror, that concave mirror always form real and inverted image except one case. If we consider the object that lie between focus and pole, in this case the image formed by this concave mirror is virtual and enlarged. That is the very important case. If we want to draw the image here, we can say this is the parallel ray, and this parallel ray, that after the reflection, that must be passing through focus. Okay, that must be passing through focus. If we consider some another ray, we can say this is our another ray. Then we have to draw a normal here, and in this manner this ray is reflected back. So if we draw two ray in backward direction, so what we can say that, guys, if you draw in this direction, and we can say that at some point that is a enlarged image is formed in the same direction, that is A dash B dash. So whenever object is kept between focus and pole in concave mirror, this will form virtual and enlarged image. What is the meaning of virtual? We can say by nature m negative and magnitude that must be greater than 1. Except this case, The concave mirror is always from real and inverted image. At the same case, if we are talking about the convex mirror, so what will happen in the case of the convex mirror? The convex mirror always form that is virtual, and diminished image. Virtual in diminished image. That's why in our vehicle that the real glass is using in the convex type of nature. Why convex type of nature? So that more number of field of view is created. That's why the small image is formed. We can say at the given time, we can say multiple image at a given time. So we can say in this case, always form virtual is means magnification is less than 0 and magnitude of magnification is less than 1. This is happening for the convex mirror. Okay. So what is the meaning of we have to understand what is the meaning of the magnification. That is the size of object. That is the size of object. Okay. Here one question is given that has come in the need. What is question say, guys? Question say object is placed on the principal axis of a concave mirror at a distance of 1.5 f. So we can say firstly we have to draw a convex mirror. Okay, so this is our convex mirror, this is our pole, and object is 1.5. The distance of object we can say if we consider object somewhere here, and this distance from the pole is given 3 by 2f, right? And consider is somewhere, focus is somewhere here. Okay. The image will be, in this problem, it asks about what is the position of image. Then we must apply the formula that v equal to, we already discussed sometimes object distance and focal length is given, then must use the formula v equal to, that is nothing but uf upon u minus f. We know that in concave mirror, what happened in the concave mirror, that focal length is negative. Okay, and if we consider the object is lie in this direction, so this is the direction of incident ray, we can say u is also taken negative minus 3 by 2f. Focal length is also negative. So we can say if we put this value here, so u is nothing but 3 by 2 into f, put the value of u here minus 3 by 2f, and this will again minus f and minus f, this will become plus f, and here minus and minus again this will become plus f. So this will become 3 by 2 f into f, and after solving this will become minus f by 2. We can say f and f is cancel out, 2 and 2 is cancel out, v is minus 3f. So image is formed at the same size of object at the distance of 3f. We can say the option A is the right one, and the position of image at the same size of object at a distance from pole is 3f. If you want to show, we can say this is the distance. We can say this is the distance where image is formed, and this distance from the pole is nothing but 3 into f. Here, one question is also come in the NEET 2016. That problem is based on the nature of the convex and concave mirror. Let's read the problem. The magnification is minus 2. If magnification is minus, what is the meaning of this? We already discussed. Suppose if magnification is negative, what is the meaning of this? So magnification is minus 2, and the magnitude of magnification, that is the 2, that is the greater than 1. So we can say height of image is greater than height of object. It means enlarged image. It means enlarged image is formed, right? Okay. If magnification is negative, it means we can say कि magnification is negative. It means height of object and height of image in opposite sense. So we can say that कि what is the negative sign? So here that is we can say कि this tells about the inverted image. This tells about the inverted image. So let's check the option. कि image is that is always real. So we can say the real image and real image and which mirror always form in large image. Convex, this is not possible in the case of the convex, that must be concave. We can say B and C. So for A, B and C is the correct. M equal to -2. If we talk about the second, M equal to -2, again, that the magnitude of the magnification, that is the less than 1, we can see in this case diminished image. In this case, diminished image. But here, again minus sign, so we can say the inverted image is formed. Inverted image. Whenever inverted image is formed, this is in nature real. So we can say there is only one mirror, that is the concave mirror, that will form real image. So we again say in this case the correct answer is one is the concave mirror. Okay. And we can say virtual image again, that is the right B and C. For the C, that magnification is +2, and we can say that in this case magnification is +2. We can say that is magnitude of magnification is greater than 1. We can say the enlarged image, and enlarged image is formed only by the concave mirror. So we can see concave mirror is also in this case, and this is the positive. What is the meaning of positive? We can say in positive means erect type of image, the same direction object and image lie. We can say erect image, and erect image is always virtual, guys. We can say in this case B and D is the right answer. B and D is the right answer. And what about M equal to half? We can say in this case erect image, and that is diminished. We can say this is also possible by convex mirror. So we can say in this case A and D is the right answer. So after considering these options, we can say option D is the right one. Next, that is the graph between 1 by V and 1 by U. Okay. Actually, if we write the equation that 1 by V plus 1 by U equal to 1 by F, we know that in the case of the concave mirror, focal length is negative. In the case of the concave mirror, focal length is negative, right? So we can say if we want to plot the graph, we have to draw. This is nothing but this is our 1 by S axis. This is our 1 by this is our 1 by V axis. In order to plot the graph, we have to separate the term something like this. 1 by V equal to 1 by U plus 1 by F. Right. Here, if we say that we put focal length is negative here, if we say that the focal length is negative here, so we can say that this is negative. So U is also, if U is, what we can say that to nothing but mx plus c. If we compare 1 by v by y, x by 1 by u, and this is nothing but the slope, and c is nothing but c is the y-intercept. Right, guys? C is the y-intercept. In this case, focal length of the concave mirror is negative, so we can say line must passing through this point. Line must passing through this point, having, we can say this is the relation, this is the relation for the concave mirror. If you want to write down this relation for the concave mirror, so we can say this is our concave mirror. Okay, so we can say slope is negative, intercept is negative. We can say the line is passing through in this manner. The line must be passing through in this manner. So this is the correct graph. This is the graph. We can say the graph for the concave mirror, that is a straight line graph, and this point is nothing but we can say this is point that we can say this is 1 by f and this is 1 by v. If we're talking about the convex mirror, we can say in the case of the convex mirror, if we write down this 1 by v minus 1 by u plus 1 by f, in this case focal length is positive. If focal length is positive, so what is the difference between two graphs? Here the y-intercept is positive. So we can say the line is passing through in this manner. We can say this point is nothing but this point is our 1 by f, and this point is we also consider our 1 by f. Okay. The next is the graph between u and v. If we want to draw the graph is u and v, so we have to write down f less than 0 here, f greater than 0 here. If we want to graph for the concave mirror, we can say this is u, this is the v. By writing the equation, we can say this is nothing but u into f divide over u minus f. That is not a exact curve, something like as a hyperbolic nature. So how we can say that if we have to draw the graph in such a manner, we can cross check that f must be less than equal to 0. So this graph is something like in this manner. We can say here we can check that our focal length in this graph that lie always in negative side. In this manner, we can say this graph is nothing but this is symmetric about the y equal to x line. We can say if this is the y equal to x line, we can say this is our focal point. In this manner, this graph is for the concave mirror. In the convex mirror, we know that the focal length of convex mirror is positive. Then how we can draw the graph? If this is u, this is v. So firstly, that is the inversion of the grid graph. We have to put f positive here. So if we take the inversion of the previous one, this will happen in this manner. Okay. And again, one is moving like in this manner. So here we can also say that in this case focal length is positive. That's why focal length lie here, positive here. Focal length is positive here, and somewhere focal length is also positive here. So in this manner, we can say this is the graph for the convex mirror. How we are going to choose the graph when there are four options are given? We have to put the f positive and say where in which graph f is lie in the positive sign. Like in the case of the convex mirror, that this is our focal point. We can say this is the lie in positive side. Positive side. So this is the convex mirror. Here the focal point that is lie in the negative side. So we can say this is our concave mirror. Just put the value in this equation and check the answer. Put u equal to f in this equation. Just put u equal to f and get the answer by cross checking the graph. What is the longitudinal magnification? Whenever object is placed along the principal axis, along the length of principal axis, something like this. Suppose this is the length of our object AB. Okay. Then what is our longitudinal magnification? So longitudinal magnification guide defined as minus times of m square, where m is nothing but linear magnification square. We can say that m is nothing but minus b by u square. So in this manner, we can say this is nothing but minus b square and u square. Sometimes longitudinal magnification asked in the problem where linear or transverse magnification are given. We can directly calculate the longitudinal magnification by squaring the transverse magnification. Let's move for the next. That is our last topic. That is the velocity of image in the spherical mirror. Okay. So what is the velocity of image along the principal axis? So suppose if we consider, suppose This is our concave mirror, and we have to find out the velocity of image. Suppose if we consider again the object is moving in this direction, then we have to take the component just similar to in the case of the plane mirror, we can say if this angle is theta, so this is the perpendicular component, and this is the component that is the parallel component. Okay, so we have to find out the velocity that is lie along the principal axis. We have to find out v perpendicular here. Okay, we know the formula that 1 by v plus 1 by u equal to 1 by f, because this is only the position or coordinate of object image and focal. In order to find out the velocity, we must differentiate this equation with respect to time. If we differentiate this d upon dt of 1 by v, that d upon dt of 1 by u. And we know that the once the mirror is fixed, then its focal length is also fixed, that d upon dt of 1 by f. So f is constant here. In order to differentiate and get the value of velocity, we can say that what is the result that will come here. We can say this is nothing but minus 1 upon v square dv upon dt, here minus 1 upon u square du upon dt, and this is the constant, we can say 0. Here, what is the dv upon dt? That is the velocity of image. What is the du upon velocity of object? We can say 1 upon v square. This is nothing but we can say this is the velocity of image with respect to mirror. We have to keep in one thing in our mind. This is the velocity with respect to mirror, and this is nothing but that is the velocity of object with respect to mirror. If we equate, we can solve this in this manner. The velocity of image with respect to mirror, this can be written as minus v square u square, and the velocity of object with respect to mirror. That is again very important formula, and we know that this is not a new term for us. We already discussed about this. This is the linear magnification square. This is the minus m square velocity of object with respect to mirror. We can say that whenever velocity of object is given along the principal axis, we have to always very careful that this velocity is along the principal axis. We can say that this is the v perpendicular. Okay, v perpendicular means we can say that this is the perpendicular to mirror, or that is the very appropriate word, that along the principal axis. We can say this is the along the PA, principal axis. So whenever object velocity is given with respect to mirror and we have to find out the image velocity, just find out the linear magnification and we can easily find out the value of the velocity of image with respect to mirror along the mirror. I hope this is useful for you, and in next lecture guys we are going to cover that is the refraction portion, that is the second part of the ray optics. Thank you very much.